So I'm going to be talking to you about the titrations worksheet, which was pages 39 and 40 out of our acids and bases pack. Okay, I'm going to be going through all the solutions to those problems. Alrighty, so let's start off at the top. It asked you to determine the hydrogen ion concentration or molarity for each of these acidic solutions and classify each acid as monoprotic, diprotic, or triprotic. Now I will tell you that in this section, I personally find it much easier to do the classification first and then look at the molarity second. All right, so let's start off by looking at our productness, meaning how many hydrogen protons are released by these acids when you put them in solution. So here we've got hydrochloric acid, has one hydrogen. That one would be monoprotic. Okay, here we've got phosphoric acid. Now you'll notice it has 3 hydrogens. That is going to make it triprotic. Next one, we've got sulfuric acid. It has 2 hydrogens. That one would be diprotic. Here we have nitric acid in number 4, 1 hydrogen, monoprotic. Next we have chromic acid, and this one would be diprotic. Okay, now let's go back to our molarities. So here we're starting off at a 2.5 molar solution. It's monoprotic, so it's only going to release 2.5 moles of hydrogen ions. Our next one is triprotic. That's our phosphoric acid. It has 2 molar acid, but it's 3 hydrogens being released. So we have to multiply our concentration by 3, and that would give us an effective concentration of it being 6 molar. Our next one, we start out as 6 molar, but it's diprotic. That means we have to multiply it by 2. That means that 6 moles of sulfuric acid will release 12 moles of hydrogen gas. Or sorry, protons, not hydrogen gas. Alrighty, our next one, we have 3 molar nitric acid. It's monoprotic. It's just going to stay 3 molar. And our last example here, 3.5 molar, but it's diprotic. That means that it will release 7 moles of protons. All right, so that's it for the top. Pretty easy, straightforward. You look at the number of protons released, and monoprotic, your answer gets multiplied by 1, which means it stays the same. Triprotic, we multiply by 3. Diprotic, we multiply by 2. Now, let's go down to the bottom at the bases. Now, in the bases, we're classifying these as either monohydroxy or dihydroxy. Means everything's going to get multiplied by 1, stays the same, or it's going to get multiplied by 2. So let's start off here. We have 2 hydroxide groups. This one will be dihydroxy. And I'm going to just go over, look at the rest. This one's going to be mono. Our next one are barium hydroxide. They have 2, so that's dihydroxy. Sometimes it's called dibasic, just so you know. Next one, 1 hydroxide group. That one's going to be mono. And our last one, we have 2, so that's di. Okay, so coming back up to number 6, we have 4 molar base, 4 molar calcium hydroxide. It is dihydroxy. That means that we have to multiply by 2 to get our concentration of our hydroxide ions. So that would be 8 molar. Our next one is mono, which means we don't do anything. It's going to stay 2 molar. Our next one is dihydroxy, and that means we are multiplying 1.5 by 2, so that is going to be 3 molar. Our next one, we are monohydroxy. It starts as 3 molar. That means it ends as 3 molar. And our last example, number 10, we're a dihydroxy base, magnesium hydroxide. Our molarity is 3.5. Since we're releasing 2 hydroxide groups, we have to multiply that by 2, and that is going to give us a molarity of 7. Alrighty, so that is our answers to pages 39. Let's go down to page 40. Now, I just asked you to do the first 4 problems here. So we're going to start off by looking at number 11. So we have a titration of 50 milliliters of vinegar or acetic acid requires 25 milliliters of 0.7 molar lithium hydroxide. What is the molarity of the vinegar? So the first thing I'm going to do is I'm going to look at my acid and my base, and I'm going to determine, are any of them di or tri? So vinegar, acetic acid, its formula is CH3COOH. That is monohydroxy, so I don't have to do anything here. My next one, lithium hydroxide, that is, hold on, I just misspoke. This one's monoprotic. Lithium hydroxide is monohydroxy. What is the molarity of the vinegar? So since they're both mono, I don't have to do anything beyond using the MAVA equals MBVB equation as written. So my molarity of my acid is my unknown. My volume of my acid is 50 milliliters. My molarity of my base is 0.7 molar. And my volume of my base is 25 milliliters. Okay, and when I work this out, I am going to get 0.35 molar. So that would be taking 0.7, multiplying it by 25, and then dividing it by 50. Essentially doing a cross multiplication to solve. Simple algebra. All right, let's go down to number 12. Here we have nitric acid, that one's mono, and we have sodium hydroxide. It is also mono, so once again, we don't have to do anything special. All right, so still using MAVA equals MBVB. Alrighty, so I am wanting to figure out what my volume is on this nitric acid. So my molarity is 0.5 molar. My unknown is my volume of acid. It is going to be equal to my molarity of my base, which is 0.3 molar, and my volume of my base, which is 100 milliliters. To solve this, I'll take 0.3, multiply it by 100. That gives me 30, and then I will divide that by 0.5, which means that my new volume will be 60 milliliters of the nitric acid. Alrighty, let's go down to number 13. In number 13, it asks, how many milliliters of a 1.5 molar barium hydroxide solution is needed to exactly neutralize 15 milliliters of a 6 molar sulfuric acid solution? Now, I want you to look at what I do here. This is an interesting one. This one's di, so is this one. So since they're both di, I would be multiplying both sides by 2, but since they're both 2, they cancel out, and I end up not having to do anything. But I'm going to show this to you with the multiplication in it, so you understand the theory behind it. So I'm going to be solving for my milliliters of base. I'm still using MAVA equals MBVB. And I am going to, let's see, start off with my molarity of my acid, which is 6 molar. And I'm going to multiply that by 2 because it's diprotic. I'm going to multiply that then my volume, which is 15 milliliters. Okay. Then on my other side, I have a 1.5 molar barium hydroxide solution. It is also di. So I'm also going to multiply it by 2. And I am solving for my volume. So if you work this out, 2 times 6 is 12. Multiply that by 15. Then you'll divide it by 3, which is 2 times 1.5. And your final answer should be 60 milliliters. Alrighty, so it would take 60 milliliters of that barium hydroxide to neutralize 15 milliliters of the 6 molar sulfuric acid. Alrighty, let's come on down to question 14, which was the last one I assigned. So you have a 30 milliliter sample of 0.5 molar hydrochloric acid, completely neutralizing 10 milliliters of potassium hydroxide. What is the molarity of the potassium hydroxide solution? So I'm going to take my 0.5 molar, that's my acid, and I'm going to multiply that by the volume of my acid, which is 30 milliliters. I am solving for the molarity of my base, and my volume of my base is 10 milliliters. So to solve this, it would be 0.5 times 30, which would give me 15. And I would divide that by 10, which means my answer is going to be 1.5 molar potassium hydroxide. Alrighty, that's all the solutions for pages 39 and 40. I hope this helps as you go over it. Please feel free to message me with any questions you might have. Have a great afternoon.